So let's start talking a little bit about the core technology elements behind Petuum Optimum. So from my understanding, we've got two main models that we're utilizing. So one is really the prediction element, and then the second is the optimization. Why don't you guys talk a little bit more about what's involved in each one of those, or maybe I'm missing something. What else is there?
Yeah, so our machine learning framework is divided into two pieces. One is called as the prediction framework, and then the next one is the optimization. So the prediction, obviously we are using cutting edge ML algorithms to understand so we take the historical data and train the models using the historical data, using ML deep learning to make sure that we are identifying patterns that are ranging for several months of is representing several months of data. Mm-hmm. And then the second framework, which is the optimization, is around which represents more of the evolution process of picking the fittest prescription in the search space that it has. And so these two models work together to provide the predictions and the prescriptions.
Got it. And so we often, whenever we're breaking this down for some of our customers, we take several different steps in order to reach that the final step whenever we actually operationalize the models, once we've gone through the configurations, the validations. And so why don't we go into each one of those? So the way that I've seen it mapped out before, first we're doing an assessment, we're doing the connections, the configuration, the validation, and then we're going live. So there's clearly a process here. And I've seen you folks use our configuration sheet for that also, because what we're really doing is we're translating the objectives of the customer into what can be consumed by the engineering folks. So, yeah. Why don't we pull up that document and just show everybody a little bit more about what that looks like and how we collaborate with our customers?
Yes, sure. I can do that. Let me just start sharing. Um, and then I will show the configuration sheet. Yeah, so essentially the information that we collect is first the variables, right? What is the tag description? So which variable we are going to be using as an input, right? Or let's say, or it could be a variable that we want to optimize, or a variable that we want to, let's say, use as a set point, for example. But that is basically the variable name. What is the tag description? Then the functional description is where we have more commentary about that variable. For example, here we are saying that the secondary temperature and a little bit more detail. And the customer tag name. This is the tag that we are going to be mapping to the process data historian. Every process data historian has a tag name associated with each variable. And the same way, every tag name has an associated description that can be a little bit longer. The units of measure, it's also very practical to use unit of measure in order to validate that we are pulling the right information. Something that is very powerful about AI is that AI really, regardless of the units of measure, can handle it. But the thing is, from the point of view of the user and configuration, it's always best to specify this. It might be additional comments from the subject matter expert. And then we have here, we can specify with an X if the specific variable is a goal that you can either maximize, minimize, or stabilize. If that is a prescription that we want to give, that we want to map to the actual set points that the operator is changing or manipulating. And then the constraints, which of these variables that we don't control directly, but if we move a set point, we will have an influence on them. What is going to be, we can specify that this is a constraint and we need to respect it. and then we can say that these uh, for example, these variables are associated to a disengagement rule, and then also we can specify if this indicates that we have a failure in a signal by indicating an X in this column.
Yeah, so Christine, I think the overall gist is that even though we have now defined a standard definition of what an asset's typical goals or prescriptions or constraints might be, I think we definitely leave room for customer to customize it to make sure that we are representing their unique asset as well as their unique process differences that they have. But we again don't want to go with a blank slate. So we do have recommendations on based on our lessons learned, right, with many customers. What is the typical goals or prescriptions they should consider?
Right. Chris, anything else you want to add about the template or the data collection process?
Right. I think Nadia just mentioned a very good point that this TAD mapping is actually a great tool for the customer and our engineers, like people like myself, to really communicate with each other without actually talking to each other, because everything's documented really nicely on this Excel sheet.
Right.
One very good example is sometimes like our customer, like they don't even know what exactly they want, like in terms of like so we have different priorities. We might want to increase the temperature. We also want to optimize the speed, and then so just in their day-to-day operation, they kind of just try this, try that, and whenever it works, it works.
Yeah.
But then whenever it comes to us as data scientists, as engineers, when we put them into perspective, into programming languages, we kind of force our customers to think about how we want to prioritize our tasks,
Yeah.
which is like learning experience for our customer as well. And then for us, of course, me as a software engineer, I don't have I should say I did not have the background knowledge of how many of the assets work, but just because of I read so many like asset tag mapping like this,
Yeah.
I really they're so clear to me that now that I actually understand how each asset works, like just only by reading this Excel. So having this domain knowledge, it really helps when we develop our machine learning models.
Right. Awesome. So now that we have identified how you're going about personalizing and collecting information, clearly the next step is also to get access to the data, right? And so why don't you guys share a little bit about what you're looking for from that data whenever it comes over to us, and what helps you assess if it's even the right data, if we have enough. What are some of the things that you guys think through and consider during that process?
Sure. So as an engineer, when we get the data, we usually when customers send us like a whole load of data, maybe they're past half a year, past the year, all of the data, and then we would organize them like tag by tag, sensor by sensor, and we would like check each of them to see whether it has outliers, whether they follow a certain pattern, and especially whether this pattern agrees with whatever pattern that we define on that aforementioned tag mapping sheet. And sometimes there are mismatches. For example, like sometimes our customer might even not realize that their sensor behavior changes over the past month.
Yeah.
So that whatever threshold we defined in the 2 months ago needs to be updated. So we would do all of that, and then once the data is clean and we have a trust in the truthfulness of our data, we will start training our model. And we have a forecasting model and optimization model. Once they are trained, then we have a dedicated QA team to test the performance of our models, making sure that they meet our like predefined requirement that we agreed with our customer. These are the like basically the performance that we will meet, and make sure we meet them, and then we deliver our product to the customers. We would run our model live on their asset, and the last step, which is also probably the most critical step, is both the customer and the engineers from our side will both monitor out the performance of that model in real time, and making sure both them and we are happy with the performance. Then we deliver the product.
Like I'm curious too, what happens if they don't have the right data or they have too little data? Then what do we do?
Yeah, so that's really the interesting back and forth between the customer and us. And I think our customer success team does a really good job in communicating between us, making like a bridge, making this communication really smooth. Whenever we find data is missing, of course, we would contact our dedicated team, customer success team, and they would reach out for customer. And usually, usually they can fix it by finding more data, or if we see that already the data pattern changed in the past month, then again, our customer success engineer would go talk with the engineer in our customer office, and they would figure out, okay, so the pattern did change, then there are two solutions. Maybe we only train our model on this recent month data so that we always see this new pattern, or we could reconfigure our goals so that we basically set a different threshold of what is considered a normal range of the data. So of course, these are kind of small details that goes different case by case, but the important thing is we do have this communication back and forth to make sure that we always meet the requirements.
Yeah.
You know, something that I feel that is a very important feature of Optimum is the ability to do outlier removal automatically, time alignment. In fact, when I talk to customers, they're always impressed about this in the pipeline. Could you, Chris, describe a little bit how is configured and what settings are typically used to achieve those things? Because we know that the frequencies are different for different variables, but how do you do that magic?
Yeah, sure. I can sure talk about how this magic happens in the back end. So whenever I have like a several amount of data, and the first thing I ask for is I don't even need to ask. I would go to our document and see um, what's the constraint bound, what's the control bound, those boundary that we set for that particular sensor. Let's say this is a pressure sensor, and the threshold we set is the maximum number of that sensor needs to be 90, and then I simply check how frequent in the past 4 months did this sensor go above 90, and then we have a threshold. Let's say I'd say this outlier frequency needs to be below 10%. So whenever I see this frequency goes above 10%, then I would alarm our customer success engineer, and then they would go talk with our customer. Basically there's a misunderstanding, like the goal that we set could not just physically could not be met, because otherwise our sensor is out of constraint most of the time, which doesn't make sense.
Mm-hmm.
So there's a good bit of pre-processing that we do.
Exactly. In any AI models and training, like actually I would say more than half of the work is understanding the data, cleaning the data, not actually like training the data. When it goes to model training, that's actually more streamlined. And the important and the difficult part is actually understanding the data, making it, formatting it so that it can be used in computers.
Got it. Unity, I'm curious, do you have any other thoughts as well as what you're looking for from the product perspective of how we go about validating this?
Absolutely. So as you already heard that we do two types of testing. One is the historical testing, and one is the streaming testing. And a lot of times we identify that what we expected of the model in the I would say historical testing probably did not match at streaming, because the data pattern changed, or the sensor position was changed from one location to the other, and so there is a delta seen, right? So we do have strategies in place in terms for product to handle those changes, where we are looking at correlations in the past to be able to sync up to it. But more importantly, I think the most important thing is that we have to actually get the site validation. So on the site, validating how our model is performing over with the asset is where the final litmus test is, because what we do internally is not on the site. So how the model is actually going to react in the real environment is can be tested only on the asset. Sometimes the customers tell us that they would give equal importance to those objectives that we want to meet. But when we actually go on site and start validating this, we might see that we want to maybe emphasize on one of the objectives even further compared to the other objectives. And so we fine tune those to make sure that we are getting the maximum output from the ML models to maximize the objectives that we want to. So again, this process is it takes about anywhere between 1 to 2 to 3 weeks, where we are fine tuning, running it at a sprints of supervised tier, where then we call that this process is complete and we operationalize.
Yeah, I'm sure over time too, the customer's objectives or their goals might change, or even on the in a real-time operating environment. Sometimes the sensors are going to have some variation or change over time. How does that affect our models, and how do we go about making sure that we keep that accuracy and keep hitting our success criteria?
That's a great point. So, we have a built-in mechanism where, we are live tracking how our model's performance is in terms of prediction accuracy. And once we start seeing a trend of, say, the prediction accuracy is decaying over a period of time, we do have, I would say, triggers in place which will automatically help us retrain the model. Taking in the data set from the latest operations to be able to then fit to make sure that we still consistently keep the prediction and prescription accuracy. So that's one thing. And the second thing is to make sure that we do talk with the customers in terms of the performance metrics that we are going to be measuring. So we do have a process where we on a I would say regular basis measure the performance against what have been defined as target thresholds that we want to target towards, and share with the customer how is our product doing against those.
To me, one of the most powerful things is this tuning of parameters that don't need retraining, like this, the weight factors. Because the thing is this, the model is still accurate, but now it could be that for a market reason, the customer now is tending to have, look, it's ready to sacrifice a little bit of a secondary temperature because they want cooler clinker because they are in a high demand, let's say. But it could be that that can last for a month. They can go back later to the previous weight factors that will enhance more than energy recovery, sacrificing temperature. But this is specific to every customer, each customer. We cannot know a priori. It's until we do, as Unati said, that we are doing the fine tuning. We understand how these weight factors will help one objective more than the other. And it's the customer decision to use one set, but that can be changed.